Hello everyone, my name is Lukyanchuk and I am one of the researchers from Central Aerohydrodynamic Institute from Russia, which also calls TSAGI. And today I'm going to talk about investigation of the influence of low amplitude loads on the fatigue life of CFRP specimens with impact damage under irregular loading. Here it is a plan of my discussion. Firstly, I'll give you some background information, then I describe the specimens which were used in this study, then I'll briefly talk about loading programs, and in the end we discuss about results of this study, and in the end we talk about conclusions. Okay. Now let's move to the background information, and for an experimental evaluation of fatigue life of aircraft structure from CFRP, loading spectra are used, and they formed on basis of data on the typical flight of an aircraft. Such spectra contain a large number of loading cycles of low amplitude. In order to optimize and at the same time preserve authenticity, it is necessary to evaluate how this type of loading affects fatigue life and what damage such cycles introduce. For this purpose, it was made the research of the effect of low amplitude loads on the fatigue life of CFRP specimens with impact damage in a cyclogram of irregular loading. Also, the evaluation of the applicability of the linear summation hypothesis of damage at this level of loading was also carried out. Now I'll describe specimens which were used in this investigation. An experimental study was conducted on specimens of two types, which was made of CFRP in the form of a strip of rectangular cross-section with central impact damage. Here it is a sketch of these specimens. First and second types differs by the impact energy applied to them and by the depth and size of impact damage correspondingly. Impact damage was applied according to standard, harmonized with ISTM D7136. The impact damage parameters for the studied specimens in the table. For the first type, impact damage depth in the range of 0.3 to 0.5 mm, and the maximum size of the impact damage is in the range of 84 mm to 100 mm. For the second type, impact damage depth in the range of 0.14 to 0.38 mm. The maximum size of impact damage in this type of specimens was in 38 to 57 millimeters. Yes, despite the fact that parameters of impact damage of the first type specimens is not characteristic of standard or ISTM, but the aim was also to obtain experimental data for the depth of damage which correspond to the parameters of damage of first category by BVID. Now let me introduce briefly our loading programs which were used in this study. Tests for fatigue life were carried out according to two irregular programs. All loading cycles of the programs used had a loading cycle asymmetry factor which equals -6. These figures shows diagrams of program blocks. The first loading program contained cycles with two different levels in the form of two steps. The percentage contribution to damage to the relative to the program block according to SN curve is the same. The second loading program, in addition to the steps of the first program, contained low-level cycles. The loading level of such cycles corresponded to the fatigue life of more than 5 million cycles. The number of cycles of the third step of loading exceeded the total number of cycles of first and second steps more than 2 times. Okay, now let's talk about the results of our study. And experimental fatigue life was compared with analytical evaluations. Analytical evaluation of fatigue life for the program block was obtained using an SN curve of regular loading with the corresponding asymmetry -6 and using the linear summation hypothesis of damage. The amount of fatigue damage in this case was as a ratio of the experimental to the analytical fatigue life. Comparison of the results of the first program and the second program are presented into this table. The results of sum of fatigue damage of the first type of specimens for the second program with low loads cannot be explained only by the spread of fatigue properties. This may be due to an unknown mechanism of damage accumulation in the specimen with an impact damage, in which the number of loading cycles is more significant for damage than the level of the acting stresses. Although one cannot exclude the effect on the fatigue of the proximity of the impact area to the free border of the specimen. Yes, in this case, impact damage area tends to halve the specimen width, which is the characteristic of some experimental specimens, but rarely found in real construction. In particular, to answer the question about the reason for the relatively low values of the sums of fatigue damage for programs with low loads, tests of the second type of specimens were conducted. However, according to the results of the study of specimens of the second type, it can be concluded that there are no nonlinear effects, provided that the recommendations of the standards regarding the size of the stress concentrators on the specimens are observed. Okay, let's move to the conclusions. At the same time, to estimate the fatigue life of specimens with impact damage compliant with the above standards and STM, a linear summation hypothesis can be applied. Cycles with low amplitudes do not introduce any non-linear effects. In the case of an evaluation of the fatigue life of specimens with impact damage, the dimension of which exceed those recommended in the standards, a deviation from the linear summation hypothesis is possible. And in this case, correction factor need to be introduced. And in the end of our discussion, we can say that impact damage for modern CFRPs should be investigated more thoroughly. Thank you for your attention. Don't hesitate to ask me a question. And thank you. Wish you good luck. Bye bye.